starts to me. So this session is also online and it is being recorded.
Security. Start कर दें. ठीक है. Share my screen actually. Share हो रहा है my screen?
No, we don't see it yet.
I don't see.
But how many people know Hare Ram?
लास्ट मीटिंग में ही देखा था सर. थोड़ा सा और बता दो.
मैं
आपके बैचमेट है. ये तो
I'm meeting first time. I'm seeing
No,
first.
not sharing so far.
not my.
So Hare Ram is actually from 97 MCA batch, my batchmate, and he's currently you are in Chennai, right? Hare Ram?
Bangalore.
Okay, yeah. And when he came to HBTI, he did not know Hindi at all. Like, nothing at all.
Okay.
Yeah.
And then were you able to learn a little bit, or it couldn't?
Yeah, he was speaking Hindi now.
Nice. That's great. That's great.
Yeah,
Because other way around is very tough. You see, other way around is very tough.
No, initially तो नहीं आता था, but otherwise उसके बाद सीख लिया. मतलब सीखने का starting then.
Oh, is it RAG today? I thought.
Yeah. RAG only, right? Because we completed the prompt engineering.
Okay.
Yeah. मैं toggle करता हूँ actually in between PPT and PDF को. Then I will start. I'll start, Manoj.
Yeah, please.
Yeah. Okay. Today's RAG, right? I think this is chapter 6 is RAG and agents. The previous chapter we studied that prompt engineering. Then in the RAG, basically what we do is to solve a task. So model need both instructions on how to do and necessary information to do. So in a given application, any application, so what models instructions are common to all queries, but whereas context is specific to each query. I think today we are more RAG when we're discussing about the more RAG. So we talk about more in the context construction, how to construct the relevant context for each query. So when we talk about contest construction, they're talking about two dominant patterns. One is the RAG, retrieval augmented generation, and another is agents. Today's session prepared for RAG patterns. Then we'll go into RAG, but then agents. I think we have to go to the next session. Today, I'll read about RAG patterns. So the RAG patterns allows the model to retrieve relevant information from external data sources. That's the main primary one, and along with our query that will come next steps. And then agentic patterns allows the model to use tools such as web search and new APIs to gather information. And they also give ability to directly interact with world, enabling them to automate the lot of activities. I think then when you talk about agentic, it become the reasoning, decision making, and performing a specific task in agentic way. I think agents will come. We'll read in next session. So then we'll move on to the what is a RAG, retrieval augmented generation. So RAG is a technique that enhances the models generation by retrieving the relevant information from external sources, the external memories. When you say here external, they talk about they're discussing about internal databases or users previous chat sessions or internet. So then this RAG actually technique is used to retrieve and generate pattern was first introduced in reading Wikipedia to answer open domain queries. I think here you see when you ask in Wikipedia the question, then it reads entire data and it will give you the content. I think list of documents. That time they called as a document reader. I think this is in dictated in the picture. So after that, this retrieval then generated pattern is coined as a like retrieval augmented generation RAG one. So RAG can be taught of a technique to construct contest specific to each query instead of using the same contest for all queries. This helps with the managing. Let's what RAG helps with the managing user data, as it allows you to handle the data specific to specific users. Basically, it will more focus towards one user query and for his contest, the contest generating your query plus taking from the external sources. So contest construction for the foundation model, I think this contest construction for foundation model is equivalent to what is talking here is in classic ML models. So we have features, right? They will use a feature engineering. I think they're saying is similar to the feature engineering. Both have the same purpose. I think they're giving the comparison contest. Basically, RAG use the that minimizing the alienations and maximize the factual grounding. I think why we use this RAG, the purpose of that. And what RAG is there is RAG is a solution for basically RAG we're using for knowledge intensive task where all available knowledge is basically I think we have a model. When we have a model, we cannot give as a prompt or input entire knowledge base available. But in the with the RAG, so only information most relevant to the particular query, what query we want to solve or what query we want to be know the more information. So that related information will be fed in. So determined by the retriever and is retrieved and input to the models. So in the model, then RAG emerges one of the most common patterns. It mainly purpose was to overcome the model contest limitations, like taking giving the more contest limitations of the earlier models. Basically. So again, they're talking about one more aspect they're giving. They're saying that no matter how long a model contest length is, there will be application that require more contest longer than that because we keep data will keep grow. So data will keep inserted in the system, and we never delete the data into the system. So that's how they're talking about. Even the another problem when we talk about contest length is more. So the model can process the long contest, does not necessarily use the contest well. So maybe we have longer contest means you might sometimes right more likely to model focus on the wrong part of the contest. And even you have long contest again that also include the extra cost as a potential to add extra latencies because you have longer the length, then that when you chunking the data, you're using the strategies that will also have some cost. Same time you have extra latency. So then the next point they're talking about RAG allows a model to use only most relevant information for each query and reduces I think since it's using the relevant information that reduces the number of input tokens. So since you are reducing the number of tokens lesser, that potentially increase the model's performance. I think that's how they're talking about here. Any okay, so now I'll move on to the RAG high level architecture. Any points to discuss? Anything? No, please feel free. So that's what we discussed until this here. They talk about RAG techniques. Then they give an Wikipedia example. Then we talk about model contest, how RAG arrays. So now next time we're driving into RAG high level architecture. So when we're talking about RAG high level architecture, there's a two main components. One we talk about retriever and generator. Basically, RAG talk about retrieval, augmentation, and generation. Then is a two component. One is a retriever. So this retriever is here. If you look at in the picture retriever, it takes the information from the external memory sources like external memory documents, charts, all the information. Then generator that generates a response based on the retrieved information. This here, if you look at when the user prompt the information, that already data we have from the external memory, and then the retriever will have a contest related queries. From the external, they will take the contest. Then the model, that LLM model, will give the prompt query as well as contest. So when we give this information, we give information to the LLMs. Then accordingly, response will be generated to the users. The success of RAG depends on the quality of its retriever. So the means the quality of retrieval means the contest related to the query. So more you have contest to the query, then it is a more success to the RAG. That means more uh, proper closure response will get it back. Then retriever also we have two functionalities mainly indexing and querying. Indexing involves process that can be quickly retrieved. Basically, how you do chunking or embedding at the later point of view, we will study on that. How the indexing we will do. I think the way we do indexing that will also help you to retrieve the data, retrieve the information faster back to the user. So sending query, I think sending a query to retrieve data related to this called a querying. So this is a basic RAG architecture. So which is given in the document. Then they
Okay,
talk about
Hariram, sorry.
yeah
Can you go back to the previous slide?
previous one.
No, no, yeah, yeah, yeah. This is the one. Let's discuss
Yeah.
some steps here because I tried to discuss there in the other class, but still I have that confusion.
Okay.
So let's say we got that from user is trying to search something, and according to this architecture, it will go to the retriever directly. With my understanding, it should go to the LLM. I mean, when we are talking, let's say Chat GPT, it is Chat GPT as an web API or whatever it is. It is directly going there. Then internally, let's say it has any other source to retrieve data, it will send internally, right? But here, why the architecture? I mean, I am not asking you. I'm just trying to ask
Yeah,
in
yeah, I
general.
understand.
Yeah, so why it is trying to go to retriever at the first? I am thinking it should go to LLM, then LLM should ask, hey, retriever, can you give me any context or information on this? I mean, that should not be, the prompt should not directly go there. I still have this confusion. Anyone
Yeah,
can?
I think I'll give my input maybe, and the rest I think Manoj can correct. See here, I'll show you the one next I want to show, but I think I'll show that one more small diagram. Look at I think this. You able to see this one? My one? No,
Yeah.
one more diagram. Okay, it's a basically meaning of what is the meaning of that? Uh, what understanding, right? When say prompt is going to retriever, so when they're saying here, no, the meaning is that you have this external data. I think you look at this. I just looked at. You're seeing this one?
Yeah, but it is obstructing your another window. Yeah, it's clear
Yeah.
now.
Now it's
Yeah, yeah, yeah. Yep.
yeah. Yeah. So basically, let's say user writes a query, right? So
Mm-hmm.
then this entire database query, everything is getting into the your vector database. So
Mm-hmm.
vector database means is there's a top part. Top part what is telling the entire you have user documents, whatever documents we have relevant
Yeah,
documents,
right, right.
everything is getting embedded. So
Yep.
the embedding, then everything is stored in the vector database. So what it happens to the parallelly here. So when query also, like whatever user query we're asking, that is also getting into embedding. Then that embedding is moving to the vector database.
Right.
So now how the vector database works here, right? I think, see now based on this query, they will take the relevant scores. I think we have next slides. My query, what is my relevant scores, right? Based on this entire earlier top knowledge base, right?
Mm.
That's where they'll get a contest, nearby contest. Yesterday, I think
Mm-hmm.
now,
Yep.
Ankur also explaining, right? I think you will do first you raise a query, then hallucinate it, then it will go to the nearby points and take the relevant scores, similarities like a quotient similarities.
Mm-hmm.
Then from there it will try to retrieve the relevant contest. So this entire exercise happens because to get the relevant contest. So
Mm-hmm.
then this entire relevant contest plus query, right? Then
Mm-hmm.
again, then this information will give it to the LLM. So LLM will generate the response back. Yeah, I think this is what my understanding when they're talking about very high level here, prompt will go directly to the retriever.
Yeah, no, this is also understood.
Yeah.
But still, my question is, let's say RAG is just an internal thing to a company or something, right? Because instead of exposing outside, you are just saying, hey, this is my information you give me. But if there is no information, let's say I gave the prompt itself is, let's say, has enough context or information, right? It doesn't need to go and retrieve from somewhere else, right? That can be possible. In that case, why do I need a vector database? Looks like in case of RAG, always I need a vector database in this architecture, right? Logically, it's not, it should not be the case. So whatever vector data, you can have an in-memory one or something. You don't need an external vector database. So I was thinking that it should go to LLM. LLM should tell, okay, hey, external RAG or somebody, do you have any information? If you have, I would apply that. Otherwise, I'll do by myself.
Yeah, so I'll give my 2 cents also. So one thing is, when you're interacting with Chat GPT, you're not directly interacting with GPT model, right?
Mhm.
You are actually interacting with an application
Exactly.
called Chat GPT that's built using that model, that uses that model, right?
Right.
So most likely, I mean, I don't know the exact internal architecture, but most likely your request goes through multiple steps. Maybe they are doing rewriting of queries, or they're augmenting the query with additional information from the internet,
Mm.
and then that composite request is going to the model to generate a response.
Mhm.
Um, so, like for you as a user, it seems like, oh, I just gave my prompt to the model, and model actually did look up whatever information it needed and generated a response. But actually, it was that application that was doing the lookup,
Right. Right.
right?
Mm.
Second is that, like, if you follow like good software architecture practices,
Mm.
like separation of concern, right?
Mm. Mm.
That's how you would also design your system, right? You will not overload your model to do generation as well as retrieval in the same component.
Mhm.
So yeah, the retrieval is like application's responsibility. It's kind of, actually, this whole RAG thing is, even though it feels like, oh, it's something new that came with LLM and all that, this technique this pattern has been there for forever, basically, for a long time, since people have been using machine learning models. Earlier, like, it used to be called request enrichment.
Mm.
So let's say you got some request to do prediction. Most likely your service would do some kind of a lookup either in the database or somewhere to
Mm.
enrich the request, and then send that enriched request to a model, right? That's
Mm.
exactly the same model that we are following here.
Yeah. So no, what you are saying makes sense to me, Manoj. I also understand that. That's why, to clarify, in this architecture, if they will put another, kind of service layer or something where prompt is going there, then it is sending to retriever, then coming, then from LLM coming there and coming back. That would have been much clarity than
Yeah,
just.
yeah, and in practice, that's what it would be, right? It will
Yeah,
not
because
be.
this is a little bit confusing. Oh,
Yeah,
why it is directly calling retriever? How does the user knows where is the retriever? All
yeah.
those. Okay, okay, makes sense. Let's move on.
Yeah, yeah. I think user might not be aware. I think this uh, yeah, maybe they're giving more context here. This
Yeah, just like Nihar sir was saying, right? If they had just drawn a box
run box.
around this whole thing, saying that this is a service that uses generative model, that would make it easier to understand from the
Yeah,
user perspective.
yeah. Okay. Yeah. So here again, RAG, right? RAG, they're talking about the retrieval algorithm. So they're talking about two types of algorithms will be used in RAG concepts. Then one is the term-based retrieval. Then one is the embedded-based retrieval. So when say term-based retrieval, I think they also call it as a lexical retrieval or spare vector used in term-based. Right. I think given a query, that the most straightforward way to find relevant documents is with keyword search, which is simple search. Some people call this approach a lexical retrieval. So I think this in these two methods they're using. One is number of times term frequency appears. Another one is the inverse document frequency with TF. I think these two methods used in. I think there's a formulas in the book. Then one is the another one is embedded based retrieval. Then they're talking about this embedded is more or relate more close to the semantic retrieval, and that's also called the dense vector. So embedded based retrieval aim to rank documents based on how closely their meaning align with the query. So this approach is called as a semantic retrieval. And again, in this we have two parts. One is indexing, and another one is the querying. Uh, First, whenever the embedding comes, again you have indexing. Then you have to query the database, query the vectors. So indexing as an extra function, they're saying that no, the converting original data into chunks into small piece of data chunks and embedding. And database, I think here, right, I think that database where generated embeddings are stored is called the vector database. I think it's not, I think there's general terms use the vector database whenever this embedding comes in, just for my understanding, in the from the readings. So then querying, then when you say only want to retrieve the data, and they're talking about two steps here. One is the embedding model steps, and another one is the retrievers. So when they're talking about embedding, I think this is where I think user query also get into the embedding, using the same embedding models when they're doing indexing. The what model they use, same model they'll use when they're doing a querying. And a retrieval. So when they're talking about fetch, that k data chunks whose embedded are closest to the query embedding and determined by the retrieval. I think here again that architecture, right? I think they talk about similar architecture. What they given one. Small adjustments. Yeah. Um, Here again, they talk about same thing, right? Here that little more explained, instead of going directly to the retrieval, they're talking about it will go to the this embedded model. So basically, it will go to your embedded model. From there, we'll go to the embedded model. Then query embedding also happens. Then it will go to retrieval. I think this is the next step. Little here, I think they talk about here, right? Index splitting embedded model. I think I read somewhere that they also talk about frameworks here. I think there's where I think they talk about this entire index box, right? They talk about frameworks. The frameworks, what frameworks you're going to use it while
राम सर आपका
using. Right?
वॉइस नहीं आ रहा.
Huh?
No, we can hear him.
मेरा नहीं आ रहा?
No, no, we can hear you fine.
I can hear you.
So I think Manoj here only, right? I think this index splitter and this embedded, I think everything is together. They also talk about frameworks. Right? Somewhere I read one of the
So yeah, actually, so the top part, right? What they're trying to show is the indexing pipeline. So let's say you have a corpus of 10,000 documents, right? Let's say your company manages documents in Confluence or some other document store, and you want to index all of those documents into a vector database. So the right document snippet can be found whenever the query comes, right? So the top part is you read that those all 10,000 documents, you split them into smaller chunks, then you use some embedding model to convert each document chunk, let's say each paragraph, into some kind of an embedding, and then you index that embedding in vector database. So now your vector database has, let's say, a million embeddings, just making it up, right? So just like million those like floating point vectors that it has indexed. Now when query comes, querying will use the same embedding model. Querying will generate some embedding for the query. Let's say you queried something in the text, right? You said, I'm just trying to figure out like what could be an example of a query. Let's say you said, find like let's say find what's the meaning of XYZ, right, in your company. So it will create an embedding of that query, that text, try to find all the relevant other embeddings from the vector database and return it to the basically. Actually, sorry. Here is this another separate, the retrieval. After finding the query embedding, after getting the query embedding, it will go to the retriever. Retrieval will try to find all the relevant, all the nearby embeddings from the vector database. So that's how it found all the relevant documents. It will combine that with the query and send it to the generative model. So it's a full pipeline. First indexing the documents, and then second part is querying.
Yeah. Yeah, makes sense, Manoj. But in this picture, in this diagram, there is a single I mean, information is flowing from vector database to retriever, which should be bidirectional actually, because retriever should ask, okay, give me that. There should be a query, but I don't know. Maybe
Yeah,
this is
yeah, you're
uh,
right. Yeah, so
okay.
it's a yeah query and then response. It's not just one way. Yeah,
Yeah, because they are creating embedding model. They want to reuse that. Otherwise, what is the point? For query, you will create another embedding model. For
yeah,
retriever, when you are getting the documents, publishing that to vector database, you will create another embedding model. They are reusing that.
yeah,
But I still have another question here. Sorry. So whenever, even I used to understand that always RAG is based on the vector database, because behind that is what is happening. And right now I am thinking, after going through yesterday's class and I didn't study that yet, but maybe we need to think of, I am not sure if I'm right or wrong, because yesterday he was saying that instead of vector database you can have a graph database also, which can
Yeah.
work better in some scenario.
yeah.
Now,
Yeah. I mean, R in RAG is retrieval, right? That retrieval could be from anywhere.
yeah,
Could be
but
vector
maybe,
database, could be Elasticsearch, could be your SQL database, could be graph database, could be just like you're looking for some information in a file, right?
yeah, but whenever we are embedding, that is what confusion is. When we are embedding, let's say here we are creating vector and we are storing the vector database. In case of graph db, is there, how did we generate an embedding to graph or something? I am not sure on that one, how
No,
that
no.
works.
Graph database does not work on the embedding. Let's say, like graph database generally works if you have like certain entities and multiple kind of relationships among those entities, right? And you're trying
Yeah.
to figure out uh, like what, given an entity, given a relationship, what are the other entities, right?
Mhm.
So those kind of use cases, graph database like really shines. So if your query is for something like that, that maybe like it needs to find who are the let's say it's a Facebook kind of a
Yeah.
right. So
Mhm.
if it needs to find what
But
are
it
all
doesn't.
your interests are, like for example,
Mhm.
and it needs to embed those list of interests in the generative model request, then yeah, you just look up in the graph database. There is no embedding involved there.
Yeah, so no, my question is, instead of embedding model here we'll have a component which will create a graph or a relationship kind of diagram and publish that.
Yes,
Okay,
that's right.
Yeah.
cool.
I think, yeah, my also understanding the knowledge graph DB, right? I think more they're using knowledge graph, right? Wherever, for example, you wanted to, let's say, you want to build a knowledge graph in the organization. For example, you are having, let's say, in case of operational risk, I mean, you have processes, you have standards, you have risk, you have frameworks that you want to do. Right? Let's say I want to do a travel to the Singapore from India. So what are the relevant information that also will give in the knowledge. I think this kind of um, knowledge graph. I think it's a graphical DB will be used, right? I think that's for my understanding. Somewhere I read that when I'm reading this.
So here we are storing vector DB, right? So vector DB is something where we are actually storing a particular word or any token in n dimension values. For example, if we are sitting in a three-dimension room, so those vectors should be my coordinates for x, y, and z. That's why here in embedding model means what we have discussed yesterday, right? So around 1,000 dimensions are there for every word. So here this vector DB is doesn't relate any relation with any graph DB. So here we are storing the vectors of each embeddings after splitting them into particular document. So this is what my understanding here is. Then we are getting those relevant embeddings in the form of vector from retriever based on our query, and then we are creating this as a relevant context to our LLM model to provide the response.
Actually, sir, I can think of a context over here.
Hmm.
So, I would like to talk about one use case. Let's say there's a hospital and it has a MySQL based database where the doctor's availability is present. Okay.
So now I want to, let's say I've made a RAG wherein a user is asking Dr. Mehta is available on Monday 10 to 11 or not. So now please understand, in this case, doctor already has a MySQL database, right? And now can someone tell me, like, when a user makes a query, is this doctor available in a specified time? So now the database is not in the vector form, right? So there are two ways now. So I'm not sure how that will work. If someone has any idea, like for example, in the case of PDF, it's very easy. Like we take the entire PDF, divide that into chunks, and then create a embedding for that and store in the vector DB. But in this case, you don't have control over the database. The hospital says I already have a MySQL based database. Now you write a RAG that can actually provide the availability of the doctor to the user. So can anyone comment on that?
It's not
Like,
a rank problem. Here you can use agents uh, to create that particular query, and then with that database, it can execute that query and give you the response.
so this is not known as RAG.
This is not rank.
No, no, actually, it can be implemented as RAG also. Like let's say in some SQL database or even in a file, let's say you have doctor schedule, right? That this doctor is available from this time to that time on that day, something like that. So query comes in, your retriever will fetch that whole schedule, could be like let's say 10 pages long, attaches that to the
One
query
thing
that saying
is
that
it is
this is
stored in the DB, right?
sorry.
So that schedule is stored in the DB in the form of some.
Yeah, it could be in a DB. Yeah. So it fetches all that, like all the whole schedule. It says that this is the query, this is the doctor's schedule, generate an answer for that. And then if somebody is asking for availability of Dr. Mehta for a particular day and time, generative model will actually look at
But
that.
my problem here is like that database in MySQL, it is not in the form of embeddings.
So what the like it doesn't have to be embedding or anything. It can be a simple MySQL query also that you're running.
Yeah.
No, but the entire RAG operates on that basis, right? Whatever query comes, it will try to
No. I
convert
think
that into
No,
embedding, and then it will
So
compare the embedding, which is closure and all.
no,
in the
Sanjeev,
book,
it's
right?
not. So retrieval is retrieval.
yeah,
So this
exactly.
embedding is just one way of retrieving information. You can
Okay.
retrieve information thousand other ways.
Okay. I
Yeah.
think tools will come into this picture, specifically for this use case.
Which
No,
tools?
I think in the book, right? I think I read
Yesterday we
like
spoke about tool
no.
concept, wherein the function calling can happen using AI
That's
Okay.
based
actually,
on the user query.
no, in the book you see that in the book also they have RAG with table data related to
Yeah.
SQL. So based on the user query, right, provide the table schema, determine what SQL is. I think basically you have data in your table, right, MySQL. Then user asking like how many units of this one. Then instead of that, user asking what is the time schedule. That text to SQL, then SQL execution. From there you can retrieve. I think this is
Okay.
one of the
Yeah.
concepts there in the book itself is based in the last.
But the point here is like embedding will not come into the picture over here.
Yeah. So one thing I want to clarify, Sanjeev, to your question, it's important to know one thing. Whenever, let's say, I am giving an example. In India, let's say Godrej company, they used to create, what is that called? Godrej Almira or something we say, right?
Mhm.
So people take that synonym to that. Okay, Almira means it's from Godrej. So the name become, hey, do you have a Godrej in your home? People will think, okay, if I. So
Yeah.
the same embedding is coming here. That RAG means people think, oh, it will be embedding. It will be this. It's just an external entity. I mean, maybe internal to your company, by which whether you embed, whether you do graph database, whether you use SQL, whether you use another way of communicating, and it just get the final database and publish that to LLM. That's all.
Right. I think
Makes sense.
very good example. Yeah.
Yeah. Okay.
Thank you.
Okay, so we'll move on the next one. Okay, next I think is again we've spoken a lot in vector database. I think they also touched upon vector database there. So vector database, I think we'll read it through quickly if you to know any other points to discuss here. Vector database stores vectors, and however the storing part is easy, but what they're talking about is hard part is vector search. given a query embedding, I think we've spoken a lot, and vector database, basically what vector database is responsible for, finding vectors in the database close to the query and returning to them. I think that's where I think vector database is responsible. And the vector has to be indexed and stored in a way that vector search fast and efficient. Basically they're talking about design or embedding techniques. So vector search is typically framed as a nearest neighbor search. For example, they're talking about k nearest vector, uh, which works that they're saying is to compute the similarity scores between the query embedding and all vectors in the database using metrics such as cosine similarities, and rank all vectors by their similarities scores and return k vectors with the highest score similarities. This they talk about the k nearest um, k nearest neighbors. And for the large data sets, I think vector search is typically done using the appropriate nearest neighbors like ANN algorithms. Some popular vectors such as libraries, like they talk about Facebook, they'll use a similarity search. They talk about Google, they're using the scalable nearest neighbors. And some there's the Spotify, ANNOA. I think there's a abbreviation also that. I think this vector database, this one. Then, in general, vector database organizes vectors into buckets or trees or graphs. I think you're talking about graphs. I think we'll see at the next session we can bring some relevance to vectors and graph database how it works. Vector search algorithm differ based on the heuristics they use to increase the likelihood that similar vectors are close to each other. A vector can also be quantized, basically reduce the precision or made sparse. So idea is that quantized and space vectors are less computational, intense to work with. I think again, the vector search algorithms are right. There are about a lot of different algorithms. What we like they're talking about LSH, and they're talking about hierarchical navigable small world and product quantity, inverse file index, and they're talking about appropriate nearest neighbor. Yeah, and Microsoft space partition tree, and different. I think all these things, right? I think there's one. I think when I Google that one, they given some more. I think when I Google that one, there's a comparison also. Let me share this one. I'm sharing. Able to see? I think my screen is refreshed. Yeah.
Yeah,
So
you can see.
here, yeah, here if you look at, right, they're about all vectors. They're about different vectors, search vectors, and they talk about what is the RAM requirements, what is the search speed, search accuracy, and how much time it will take to build indexes, right? Index building time, scalability, disk uses, and support and disk search. But it looks like as each one will have different purposes. I think we can have look at these vector search matches and which is the more. I think based on our use case, maybe we can use the most relevant vector search methods to give the contest on that. Okay, so then moving back to here, and they're about features. I think that's comparing with term retrieval and embedded retrievals. I think there's a features. For example, is a focus term retrieval. They most focus on keyword terms, and this is embedded is focusing on semantic similarities. And the representations, I think mostly is the keywords. And when you talk about numericals like embeddings here, I think matchings with criteria like they're talking about exact matching or appropriate matching, but here they talk about nearest neighbor searching vectors. And understanding, there's a limited semantic understanding, but here more capture the contest understanding here. The performance, I think they're talking about term retrieval, more or less a faster for small data sets, but less scalable. But here embedded, they're talking about more efficient at scale with optimized data structures, and they're talking about scalability. I think scalability is can be scalable with inverted indexes. I'm not but here they talk about, but require especially data structure to efficient search here. So example, they're talking about keyword search engines here. They're cementing search engines, RAG systems, basically recommended systems. So to summarize, the quality of RAG system should be evaluated both component by component and end to end. To do this, you should do the following: evaluate the retrieval quality. I think evaluate the final RAG outputs, then evaluate the embeddings. Basically, when you're talking embedding based retrievals, this is the more the RAG one. So now we'll move on to the retrieval optimizations. I think once we have a data embedded vector databases, then they're moving to retrieval optimization. I think they talk about the four different techniques. They're talking about the optimizing the retrievals. They're talking about chunking strategy, re-ranking, query rewriting, and contextual retrieval. So here, the first technique tactics they're talking about chunking strategy. So basically, how your data should be indexed depending on how you intend to retrieve it later. And chunking strategy use significantly the strategy you use mostly will be impact on the performance of your retrieval system that we need to take care. And the simplest strategy is in the book mentioned that no chunk data into equal lengths based on the certain units, and the common units are they're talking about characters or words or sentence or paragraphs. You can also split documents recursively using some incremental small units, unit by unit, and fit into your maximum chunk size. They're referring here size of the chunk. When document is split into chunks without overlap, I think there's one more consideration when you using the chunking strategy. They're talking about it is you should have some minimum overlap. Otherwise, what happens is if you don't have overlap, chunks might be cut off in the middle of important contest. That may be losing. There may be the loss of critical information. For example, I left my wife a note. If the split into I left my wife and a note. For example, if you split chunk like that, I think the original content is lost. So that's why they talk about some 20 characters or some characters. There is no hard and fast rule, but I think they say overlap is always better so that you have the original context. Then next one, I think you can also sync documents using tokens. I think not only the words and all information. I think they're talking about when you use the Llama 3 generative model. I think you can use a tokenization. I think tokenize fit into tokenizations. I think another when you chunking, they're talking about smaller chunk size. They say you have more smaller, the more diverse information you will have that you can fit more chunks into model contest. If half the chunk size, I think then chunks will be more. They're talking about the more wider information which enable and produce the better results. But smaller chunks, however, I think is like we need to take a balanced approach by reading this. So it maybe cause the loss of importance information because like what we see in the previous scenario, and also it will also maybe increase overcome. I think the more you chunk, right, that more normalization kind of thing, then you'll have more computational overhead. I think what they're saying is there is no universal best chunk size or overlap sizes. I think we have to find, we need to experiment and find what best works for us. I think in the chunking strategy also I see one small, they talked about it. If you see here, I think chunking strategy talking about they also chunk again. I think always I think RAG whenever I seen that I think they always talk about vector database. I think all chunks will again is getting into embedded. Then user query also will get into embedded and use the most similar case such and retrieval prompt and chunk will give it to LLM. Then you will get a response. Uh, uh, this is chunking strategy. Then next they're talking about re-ranking. So so you have initial document ranking generated by the retriever, can further re-rank to give the more accurate information. So re-ranking is especially useful when you need reduce the number of retrieved documents, either to fit them into your model context or reduce the number of input tokens. Um, Documents, I think, is what approach they use more on time. For example, if the documents are getting frequently changing, that will give more weightage to the recent data. They talk about re-rank will be used for time-sensitive applications such as news aggregator, chart with your emails. I think in that contest, one this rack system, right? Re-ranking, right? I think it's one I gone through here. So what they're talking about here is when you have a rack system, then you have a query, user as a query, then you have semantics, right? Then we have a vector data which it will go, And first it will retrieve the similarities like a top k chunks, all the chunks. Then this pass chunks is given to the re-ranker. So the step 3 is they'll give the re-ranker. So then re-ranker will give all this information like your top chain query and evaluated prompts and give it to the LLM, your LLM model, whatever LLM model we choose. Then this will give the re-ranked chunks, let's say step 5. And after that, I think you have a cross encoder, a by encoder, there's other methods where you will get pass into that and will get more related information. I think is more closer to the user context. Um, Anyone want to add anything, any other information here? Re-ranking, if any, I think I thought this represents a little better.
Yeah, it is.
Huh?
It's a good information to know. I didn't know these are the things happening. Okay.
Yeah, it will definitely rank. Basically, it's optimization. Then another technique they talk about query rewriting. Also is also reforming, right? I think once you have query, like saying one user asked, when was the last time John Doe brought something from us? So then they search the database given. And similarly, I think how about Emily Doe, right? So then again, that rewrite happens in the LLM to understand like when was the last time Emily Doy brought something from us. I think that's a rewriting internal technique to optimize the retrieval technique. So there's another technique. Then they talk about the contextual retrieval. The idea behind contextual retrieval is to augment each chunk with relevant context to make it easier retrieve the chunk. The simplest technique is to augment a chunk like metadata like tags. I think when they talk about tags or keywords to give the context to the retriever. So for e-commerce product, they talk about description, reviews, images, videos can be queried by their title and captions. Basically, they're talking about like chunk, right? When customer support asked, you can augment each article with related questions. For example, article on how to reset your password can be augmented. So like how to reset the password, I forgot the password, I forgot my password, I can't log in, even help. Uh, like I can't find my account. I think all these things can be context retrieval related. Maybe the one article, but might have different chunks of information. So here, I think I'll just come to the last. If any, you rag beyond the text they talked about. Not only text. I think so far we shown the most of the things are in text. RAG also work beyond the text. Text they're talking about your generator is a multimodal. The context might be augmented not only with the text, also with the images, videos, audios, or from external sources. I think here they're talking about you have a database, text database, then you also will have image database. So when user queries, I think that retriever will ask, I think is yeah, it should be bidirectional to represent saying that retriever will ask, give the text and image databases. At the same time, this question also will go to retriever, and here they're talking about this. I think everything will again convert, even the images also convert into or embedded models. I think that techniques they'll use internally. What how the techniques used, I think we had to explore more information on that. Then they say what is the color of the top of the house, and then based on your text and your image, it will pop up the information here. Basically, book talked about is not only with the text, I think only with images also. I think this we already seen with the RAG with tabular data also. It is not only with the images, I think it also talks about text to SQL execution generations. So this is the end of the RAG today. So we gone through till RAG. I think agents, I'm not prepared. Maybe next session we will take for the agents. I think this gone into 585.
This is great. Yeah.
Yeah. So here we gone through till 558. I think agents we have to take it in the next session that we will prepare it.
So Hariram, will you cover the agent section also, or do we need another volunteer for that?
I'll cover that one. I'll prepare that one also. Then maybe we can supplement it. Yeah, we can discuss.
Thank you.
Cool. Yeah, awesome. So one general question here, I mean, just a discussion. I have heard yesterday also, I think Ankur was saying, for RAG, the success rate is low. You are saying, I'm not sure. Let's say if LLM success rate is, let's say 80%, we consider that as a great LLM, right? So for RAG, he was saying success rate is even lower or something like that. I'm not sure, but
Success rate of what?
so let's say sometimes hallucinate. You are asking some questions, you are not getting appropriate answer, right? With respect to, let's say, LLM, you are asking. Let's say one LLM is tuned for medical data or something like that, and now you are a medical company or something, and internally you have some data which you are publishing using RAG, let's say, and so your query came and it went to RAG. So when it retrieves and give it to the LLM, what is the success rate there? I should consider that, yeah, my retriever is working absolutely fine or something. Is there any benchmark or something? Because yesterday he was showing,
I,
he was
I
saying,
think talk about some model scores. I think like FN score or there's some scores are there, right? Accuracy score.
yeah, accuracy
I think
score, let's say.
yeah, yeah. Generally, I think accuracy. I think my understanding. I think there's 70, 80% also. I think depends on the maturity of the model. They will consider as a good ones. Not necessarily always which are 95%. I think you have again more accuracy. They may be there is doing over doing kind of thing. They'll say was you have to train more again data. I think you have to look at that model if it gives really uh, more accuracy. I think it is in the traditional ML models what I'm referring here.
Yeah,
Um,
but you are talking about ML model. I'm talking
yeah,
specifically if your ML model is relying on RAG, what should be the success score there? Any benchmark, any
Yeah,
idea?
what I have heard is like it's around 80%.
Is it better than the model success rate or it's lower than the model success rate?
So why they are comparing model success rate with the RAG success? I am confused on that itself.
No, because
It
we are
will impact overall, right? It will impact overall success.
Yeah, like
There are two parts to it. One is like the model success rate greatly depends upon how the model has been trained, fine tuned, and like how complex is the model, right? If it is a more billion parameter, it will be more accurate. But RAG is again depending on a lot of other things, how chunking has happened, all those things. But benchmark, as I said, like what I have read, it's around 80% for RAG, right? And model, it's a different story. I mean, it cannot be compared actually.
okay, yeah.
Yeah, I mean, I think retrieval and model, their accuracy are two very different things, right? Uh, but if we say that, let's say, if model had some 80% was considered as a good benchmark, then RAG the whole architecture, like including retrieval, it should improve that score, right? Because now you are providing it more and more relevant information.
Right.
Yeah, but otherwise, I'm not aware.
Yeah,
Maybe we can ask Ankur which benchmark was he referring to.
maybe I was confused or something. But another thing here is it's not always, let's say, there is some data inside your company which even you try ask LLM, it cannot answer because it doesn't know. There is no web crawling or something. So
Yeah.
the information that is very private, we are exposing that through RAG, right? It's
Hmm. That is true.
So the idea here is like if it is this kind of a sensitive use case, we are gonna deploy LLM locally or a private cloud so that the privacy concerns won't be there.
Yeah. I mean, even though all these companies they say that we don't use query data to train our LLM, but I mean you don't know for sure, right? What that company is doing. So yeah, what Sanjeev said is right. That if you want to be 100% sure, then you want to host it within your own private network.
cool. I mean, it's we are in time. Everything is looks very perfect today.
Yeah. Yeah, thank you.
Yesterday, you know what? We extended, I think, 30 minutes. Still, they were discussing. I had some work. I need to drop.
Let me ask this. Yesterday there was some code discussed.
Yeah, because he was showing some code for.
इसलिए embedding, how do we do the embeddings? उसका कैसे
It
marking
was
करते हैं?
yesterday that vector database and what is the next one? E something something. I forgot.
Embedding, right?
Yeah, he was showing how to do all those things. That's a good one.
There are four more chapters left in this book, right? Um,
Yeah.
Agent fine tuning and what else? Conclusion.
Inference architecture.
there's some AI architecture also that I saw. Let me check. So yeah, I think we should have one volunteer per chapter, uh, and if we know that volunteer ahead of time, like it's beneficial for all of us, right? Presenter as well as listeners. Maybe Bobby, we can have some offline discussion on that on the WhatsApp group.
I agree.
All right.
Will you be
Thank you.
available after the
Nice
call?
meeting everyone.
Will you be available after the call for my phone call?
Yeah. Let's.
Thank you, guys.
Thanks.
Thank you.
Thank you, Hariram.
Thank you.